Yeah, good evening. In the last video, I think just we started double linked list. I think I have explained some basic functions regarding double linked list. Anyway, somewhat confusion is there. Let us start from the beginning, and even that old program data is also gone. Okay. Now, sir, we are going to practice the programs in this Eclipse IDE. I'm going to create a new Java project. Okay. A new Java project I am selecting. Okay, so and here the project name is something like I will give 7 p.m. Okay, our batch title I am giving. Yes, so in this I will create a new class. The name of the class is DLL, double linked list. Okay, to run the program I'm creating one more class, so which is nothing but always a test. Okay, this is nothing but what we have. So to run the main program, we have taken this test class. So compulsory main method is required. I am taking public static void main and within bracket string array args. Anyway, our entire code we are going to run from here, and class double linked list is there. Listen carefully. So here we have to implement that double linked list concept, sir. Okay. So listen carefully how it. Sir, here what are the required things? First, I am going to take node head. Okay, node head. And what is the size value? Initially, size is equal to 0. And the class I am taking node. This node class contain data field. Okay, and the node next field we have, and then previous field also. And I am taking a constructor which is receiving these three parameters like data and next field and then previous field. Like this, it is going to receive three fields. So current data will become data, and this data your next node is pointing to, so next whatever you have given, and this dot previous node is pointing to the previous. Like this I have given. So whenever a new object is created, a new node is created, I am incrementing size plus plus. This is nothing but node class what we have. And I think we have seen already display function, print function, like a traverse function we have seen. So if head is equal to null, that means if there is no head, then I am going to print. So system dot out dot println. So my list is empty. Okay, so my list is empty, something like this, and then I will return the content. So otherwise what we have to do, I think after returning no need to write any else, directly we can take. So node I am taking current node. Okay, my current node is always pointing to head. My current node is always pointing to head. So while your current node is not equal to null, if it is not equal to null, system dot out dot print of I am taking, so current node dot data. Okay, current node dot data I am taking. So next, and after that we are going to give some arrow marks here to point to the next node. Like this I am taking. Then so current node is equal to, so I am taking current node dot next, which is pointing to the next field. So after completion of this, just I want to print null pointer, that's all. Like this we have. So I think I explained already, same whatever we have seen in the single linked list, same concept. Now I will create one object for double linked list is equal to new double linked list. So initially I want to print the value. So I want to traverse the values. Okay, so I will call the method called traverse. Now I want to execute this. Just if you run, I think nothing is there, right? We are getting list is empty. So because we don't have any elements in the list, so my list became empty. Like this we have. Okay, sir, fine. Now my requirement is I want to implement one function called add first. So I want to add objects at very first location. Sir, it is going to take the data which object you want to insert. Suppose consider here, so I want to insert list dot add first of Consider I want to add something like 444. Okay, then so list dot add first of I want to take something like 333. Then list dot add first of I want to take 222. Then list dot add first of I want to take 111. So that my list will become 111. Next node is 222. Next node is 333. Next node is 444. Next node is nothing but a null. So, but anyway, we have to implement this function first of all. Okay, let us see how it will be. Sir, very, very easy. Listen carefully. Sir, first I'm creating a new node. New node is equal to, so new node of data field, and the next field is null, previous field is also null. A node will be created in this state. Suppose if head is equal to null, that means what? If there is no any node, then your head node will become new node. Okay, your head node will become new node. Suppose if node is already there, then we have to use some three statements like head dot previous will become new node. Then so new node next field is nothing but a head pointer. Then your head pointer will become new node. Like this I am taking. Sir, first I will explain how it is going to work with the help of a small diagram. Have a look once. Listen carefully, friends. So here, assume my linked list is empty. I want to create a new list. This is nothing but new node what I have. Okay. So since it is a double linked list, we have two fields are there. Consider data is 444. Sir, is there any head node? No, your head is pointing to null. So your head is pointing to null. There is no node already. So if head is equal to null, yes, head is equal to null, then this node will become head node. Okay, this node will become head node. That's all. So this will become null, this will become null. Like this, we are going to get. Suppose consider already I have one head node is there. Okay, already I have one head node is there. Consider this is nothing but a head node. Okay, head node, the data is nothing but a 44. Previous field is null, next field is null. Now I want to add 33 at very beginning. Okay, this is nothing but 33 what we have. And what is the node this one? New node, right? This is nothing but new node. Sir, is head is equal to null? No. Then head tends to previous. Head tends to previous will become new node. This will be gone. Its previous is nothing but new. And new node tends to next is equal to head. Anyway, this is already null. Now onwards, head is nothing but this one. Like this we have. Sir, consider already these two elements are there. This is nothing but null, and the next field is pointing to this one. Okay, this is null 44, and this previous node is nothing but this one, and this is 33. And what is the name of this node? Head. Like this we have. I want to insert one more. Consider it is nothing but new. Same algorithm. New node. Consider this data is 22. Previous will become null. Next will become null. Name of this node is nothing but new node. Sir, if head is equal to null, no, head is not equal to null. Head tends to previous will become new node. So head tends to previous will become new node. This will be gone. So new node tends to next will become head node. Then this will become head node. This will be gone. Okay, like this, a new node is going to be created in this case. Can you please confirm everyone? Is this concept is clear for you people, friends? Please respond, everyone. Is the concept is clear for you people, friends? I request everyone to please respond. Right, sir. Now I want to execute this code. Let us cross check whether this data is added or not. Sir, is the data is added? Yes, 111, 222, 333, 444. Perfectly in which order we have added, in the same order we got. Sir, same style, I want to implement one more method. In the same style, I want to implement one more method, which is nothing but void add last. Same, it will take a data object, and I want to create a new node. New node is equal to, so new node of, I am taking data field, so null field, null field. Yes, a new node object got created. Suppose if your head is equal to null, then your head will become new node because that is the newly created node. Suppose if there is already head node is there, pointers are same. Okay, pointers are same, but you have to traverse, right? So node, so current node will become head node. So until your current node next field is not equal to null, then what we have to do? So your current node is equal to, so your current node dot next, keep on moving to the ending later. So your current node next pointer is pointing to new node, and so new node previous pointer is pointing to the current node. That's all, sir. So I will explain with an example. Have a look once. Consider I have already some nodes are there, otherwise a head is equal to initially null. We don't have any node now. So I want to insert triple one. This is nothing but consider a new node. So I want to insert triple one. This is nothing but new node what I have. Sir, is head is equal to null? Is head is equal to null? Yes, head is equal to null. So what it is going to do? Head will become new node. This will become head. This will become head, and this head will be gone. Now I want to insert one more, add at last. Sir, I'm creating a new node here. I'm creating a new node here. This will become new node. Okay. And now it is not new node. So consider its value is nothing but triple two. Next field is null. Previous field is null. And here also previous field is null. Next field is null. Now listen carefully. Sir, is head is equal to null? No. Then new node will become current node. Sorry, current node is equal to head. So this will pointing to current node. Okay, this will pointing to current node. So this is pointing to the current node. Sir, current node tends to next is not equal to null. Sir, current node next field null, right? That means this condition is not satisfied. Then current node next field is equal to new node. Current node next field is nothing but new. Similarly, new node previous field is nothing but current. Like this we have maintained. Sir, consider I have these two nodes are there. Okay, this is nothing but I have triple one. Okay, and one more node is there like this. So this is nothing but triple two. Next node is null. This previous is nothing but this one, and this one is null, and this node is nothing but head node. Now I want to create a new node. Add last, right? It will be always adding at last. Consider its value is a triple three. What is the name of this node? It will become new node. Next field is null. Previous field is null. Now listen carefully. Sir, is head is equal to null? No. So then current node is equal to head. This node will become current node. This node will become current. Current node next field. That means this one. Is it equal to null? No, it is not equal to null. Then current node is equal to current node tends to next. Now this will become current. Sir, is current node next field is not equal to null? No, it is null, right? So that's why, so it will come out from the loop. Current node next field is equal to new node. Current node next field will become new node. And new node previous field will become current node. That's all. Like that, objects will be added. Sir, can you please cross check? So in the place of add first, let me take add last. Okay. So I want to do add last. Consider same example. So first I want to add triple one. Okay, I want to add add last. Sir, is it added at last? Yes. So it is added at last. You can able to cross check. Now, so list dot add last of, I want to add, what is the second node that we have inserted? Triple two. Let me run. Is it added at last? Yes, perfectly. Now, so list dot add last of, I want to add triple three. Is it added? Yes. So like this, we can perform which operation? Add last one. Okay. So I hope you people got very clear clarity about add first and add last methods. Okay. So DLL add first. So DLL add last. Sir, can you please confirm? Do you have any doubts about this add last method, everyone? Is it clear, everyone? I request everyone to please respond. Requesting everyone to please respond, sir. Clear, right? Now, sir, what is the next one? Add first, add last completed. So add first, add last completed. We know very well about this. Now, sir, inserting the data at a specified position. Okay. So means what? Void add. Okay. Add at a specific position. Like this, I'm taking integer data. We have to provide the position also. Sir, I am taking I is equal to 0 because we have to count the position. So if your position is less than 0 or if your position is greater than or equal to size. So means what? More than one element is, if the position exceeds that particular limit, then we are going to print the message saying out of range and then return the control. Sir, otherwise create a new node like this with the data. Next field is nothing but null. Previous field is also null. Then suppose if head is equal to null, then what we are doing? So we have to change. So your head will become new node. Your head will become new node. Then immediately return the control. Okay, sir, my head is not equal to null. Okay, my head is not equal to null. So if your head is not equal to null, then check the condition. What is that condition? Sir, is position is not equal to 0. Because if position is equal to 0, what will happen? Again, so you have to insert at beginning, right? So consider if position is 0. That means what? We are inserting at beginning location. Sir, we have seen already how to insert at beginning. Suppose if you have a list like this one and here 2. Okay, here we have 1. We have next field as a 2. Okay, so next field as a 3. So next field as null and this previous field also null. Like this, if you have, then what we are going to do? So we have to create a new node at 0th position. Here I want to create a new node. Consider it is 9. This will become head node, right? So what we have to do? This will become new node. Already we know instructions. So your new node next field will become head node, right? And your head node previous field will become new node. Okay, then your head node will become new node. This instruction already we have seen. Inserting at first. Sir, if a position is not equal to 0, what we have to do? Sir, we have to traverse so till to reach that particular position. So current node will become head node and I need some temporary node which is always null. So while current node dot next field is not equal to null, at the same time, if I value is less than position, so then your temp will become current node and your current node will become next node. That is nothing but a current node dot next and I plus plus. Now here the situation will come. So after traversing at last term, temp dot next is equal to new node. So new node dot previous will become temp. So new node dot next will become current node. Current node dot previous will become new node. Like this you have to take. Anyway, I will explain. Sir, already I have covered this code. That's why I'm not explaining. I'm concentrating on this position. Now consider listen carefully with respect to diagram I'm taking. Already I have some are there, like this is nothing but 1. So next field is nothing but something like 3. So next field is nothing but I have 5. So next field is nothing but I have something like 7. Next field is null. Previous field is nothing but this one. Previous field is nothing but this one. Previous field is nothing but this one. Next field is null. So I want to insert at a position 0, 1, 2, 2. In the second position, I want to insert the data called 4. Is position is equal to 2. Is it less than 0? No. What is the size? 4 elements. Is position is greater? No. Then create a new node. Okay. Anyway, I know here it will be created. So that's why I'm taking here itself. New node. Better I will change the color to understand clearly. So I'm creating a new node here. Okay. So what is the content? 4 is the content. This node name is nothing but new node and the previous field is null. Next field is null. Now observe carefully what is going to be happen. So is head is equal to null. This is my head pointer, right? Is it null? No. Then is position is not equal to 0? Yes. Then current node is equal to head. This will become current node. Fine. Then temp is equal to null. What is the initial value of I? It is 0. Consider I value is equal to 0. Now observe carefully. Sir, is current next field is not equal to null? This is the current node. Next field is not equal to null. Correct. And I less than position, 0 less than 2. Yes, true. That means what? Temp will become current. This will become temporary node. This will become temporary node. And current node is equal to current node tends to next. Now this will become current. Sir, I think you got clarity why I have changed this one. Because previous node I am holding, next node I am pointing. Why? Because if you want to insert in this gap, okay, this node next field, this node previous field we have to capture. That's the reason. So I plus plus. Now I value will become 1. While current node is this one. Sir, is next field is not equal to null? Yes. I less than position. Is 1 less than 2? Perfectly working, sir. Temp will become current. Now this will become temporary node. This will become temporary node. Then current node will become current node tends to next. This will become what? Current node. Like this we have. Now, sir, I plus plus. Now I value will become 2. Next current node next field is not equal to null. Yes, really it is not equal to null. But I less than position, false. That means we came to the correct position to insert. Now observe these 4 pointers. It is very easy to understand. Temp tends to next will become new. This is a temp, right? This next field is nothing but next node. Okay. Then, sir, new node tends to previous is equal to temp. This is the new node, right? This is the new node, right? New node previous is equal to temp. Perfect. Still two more links are there. New node next field will become current. So new node next field will become current. Sir, current node previous will become new node. Current node previous will become new. Like this, you have to change, sir. So by default, this data is inserted or not? Yes. Sir, if it is clear for you people, I will execute this code and I will show you. Can you please confirm? Is the concept is clear for you people? Everyone, please respond. Clear, everyone? Right. Now I will execute this code. Now see what will happen. Assume add last of 111. I am taking 333. So I am taking 555. So list dot add last of, I am taking 777. Like this, I have some items are there. So if you print the list, we are getting something like this. Sir, in between this, I want to insert the node 9. Okay, in between this, I want to insert the node 9. Sir, let us see here. List dot, okay. So list dot add position of, I want to insert 999 at 0th position. After this, I want to traverse the list. Sir, will it works? Okay, will it works? Let me cross check. Sir, are you seeing that 999 got added at first, right? Yes, perfectly it got added. Now, sir, I want to add it at first position. I want to add at first position. Is it added? Yes. Sir, I want to add at second position. Sir, is it added at second place? Yes. 0, 1, 2. I want to add at third place. Yes. Sir, I want to add at fourth place. Sir, out of range because 0th position, first position, second position, third position. So position 4 is not there. That's why out of range we got remaining elements. So I think how you can able to work with these, it is very clear for you people guys, right? Any doubts up to this, friends? Please confirm everyone. Any doubts up to this, friends? Please confirm everyone. Now, so let us go for the next type of insertion, sorted insertion. Sorted insertion we will see. What function we have to take for sorted insertion? Void sorted insert ascending order I will take integer data. Sir, it is same like insertion. Node, I am creating a new node is equal to, so new node of data field. Next one is null, next one is null. Then we need some current node is equal to head. First, I will check if the head node, that is current node, is equal to null. If current node is equal to null, then the node which you have inserted will become head node and we have to return the content. Otherwise, we have to check some condition. What is that condition? If current node dot data, that means if the first data is greater than the data, means what we have to do. So new node dot next will become head. So head dot previous will become new node. Anyway, I will explain this code, don't worry. So your head will become new node and then you have to return. Sir, when this particular thing is going to be happen, consider already some node is there. So 222. Next node is nothing but 333. Next node is nothing but 344. Like this we have next field is anyway null. Sir, now I want to insert the node at 311. 311 means definitely we know it will come in the beginning. It will become new node. And this is nothing but head. Sir, current node head is not equal to null, right? Head is equal to null? No. Current node data. Current node is nothing but this one. Its data is 322. Is it greater than 311? Yes. Then new node tends to next will become head node. Head node tends to previous will become new node. Then this will be gone and this will become head node. That is a simple thing, sir, what we have. Sir, if this condition is failed, then what we have to do? Sir, we have to write a while loop to traverse the control. Current node next field is not equal to null. Okay. At the same time, so current node next field data should be less than our data. So till that, so you have to move current node is equal to current node dot next. Keep on moving the current until last. Sir, after this, what we have to do? You need to cross check. Is current node next field is not equal to null means then we have to write certain code. If a current node next field is null means we have to write some code. I will explain why we have to take these two blocks. Only because of double linked list we have these things, sir. Okay, otherwise unnecessary exceptions we are going to get, null pointer exceptions. So if it is the case, then new node, 4 pointers we have to take. New node next field will become, so current node next field. Okay, so current node next field, previous field will become new node. Then, so current node next field will become new node. So new node previous field will become current node. Let me check how it is going to work. I explained already this case, right? Directly I'm going for this while loop, something like this. Now, listen carefully. So consider already some data is there where this is nothing but a first node or this is nothing but a first node what I have. So content is a triple one. Next field is this, next previous field is there. So this is nothing but a triple two. So next field is nothing but this one. Next field is nothing but this one. Like this we have null, and here we have triple five, and here we have triple three. So now I want to insert a new node. This will become what? Head node. So I want to insert a new node. Content is triple four. So because I know it is going to be added here. This will become new node. 1 second. Now, see here, sir. Second. Yeah, sir. Which one is nothing but a current node here? This one will become current. So what is the data? Triple four. These fields are nothing but null. Now, sir, current node data triple one. Is it greater than this data? No, condition false. So that's why while current node next field, current node is this one, next field is not equal to null. Yes. And the current node next field's data, that is triple two, is it less than triple four? Yes. Then both conditions are satisfied. Current node will become current node next. This will become current node now. Okay. Now, sir, current node next is not equal to null. Current node next data triple three. So is it less than triple four? Yes. Then what will happen? Sir, we are going to move current node here. Now, current node next field is not equal to null. Current node next field data is triple five. So is it less than triple four? No, condition not satisfied. Now listen carefully. It will come out from this loop. Current node next field is not equal to null. This is the current node. Next field is not equal to null. Because if next field is null, that means if it is the last item, then you can't fetch previous all these things on these pointers, right? That's why separate code. I will explain that part also. So now next field is not equal to null. Now what happens? Sir, new node tends to next. This is the new node. New node tends to next is nothing but current node next. Current node next is this one. New node next will become this one. So current node next is this one. Tends to previous. That means this previous will become new node. Then current node next will become new node. Current node next node will become new node. New node previous will become current. Like this we have changed. Suppose consider I want to insert a node at the last. I want to insert node at the last. Consider this will become new node. Then what will happen? Sir, current node will come up to here, right? Okay. Sir, current node next is null. It will come out from this node. Is current node next field is not equal to null? No, current node next field is null. That means previous links won't be there. Only next links we have to change. Current node next is equal to new node. Current node next node is equal to new node. New node previous will become current. That's all. Only these two links we have to write. When, if the next node is empty. If next node is not empty, we have to change these 4 pointers. Remember this. This is happens only for double linked list. If it is a single linked list, not required. Sir, I hope you people got very clear clarity about this sorted insertion in ascending order. Can you please confirm? Is it clear up to this? Sir, clear up to this? Please confirm everyone. Now, sir, if you have written for sorted insertion in ascending order, same process will be there for descending order, right? What thing we have to take? You need to take DESE, and here in the place of greater than, less than. So here in the place of less than, greater than, everything will become same. Now I am writing driver code. Listen carefully. So list dot sorted insertion ascending order of 555. So list dot sorted insertion order ascending order of 311. Let us see these two are added in according to the order. Yes, 311, 355. Now list dot sorted insertion of ascending order of 999. Is it added at the ending? Yes. Now list dot sorted insertion ascending order of 666. Will it added after 555? Yes. Now I am taking list dot sorted insertion order of 222. Sir, is it added at specified position? Yes. Now I want to add 333. List dot sorted insertion order of 444. Sir, is it added at specific position? Yes. Now I need to work with the descending. Sorted insert DESE. Now see, same output in the descending order we have to get. Came or not? Yes. This is nothing but how you can apply this sorted insertion, ascending order and descending order. Even traversing also I completed. Can you please confirm, is the concept is clear for you people? I request everyone to please respond. Is it clear for you people? Right, sir. So anyway, remaining things we will discuss tomorrow. Sir, tomorrow we have class is there, right? Do you remember the timings? Yes, spring handling. Spring handling tomorrow 7:30 we have class. Same link, regular class link you have to use. 7:30 to maybe I will take up to 9:30. Okay, 7:30 to 9:30. Right. No, no, not 1 hour. String handling first class. Sir, so much of information you are going to get from this. Don't miss the class. Okay, don't miss the class. If you want, I will show you the syllabus also. Please, 1 second. This is nothing but the syllabus what we are going to discuss. Your notes I will share tomorrow, sir. Please remind me because now I have class. So introduction to string, mutability, immutability, heap and SCP areas, string class constructors methods, string buffer class constructors methods, string builder class constructors and methods, string buffer versus string builder, string tokenizer, programs on string, string buffer, string builder, string tokenizer, regular expression and its applications. Almost 30 programs we are going to discuss on this. Okay. Yeah, we will see. Right, sir. So we will discuss in detail about tomorrow class. Okay. Right. Thank you. I will upload the running notes after 9 o'clock, sir. Okay. Because I have emergency class. Thank you. Good night.